Students, now we are going to solve another one example, that is example number 10. Example 10. So in this example, we have a question. Prove that we have xy plus yz plus zx is equals to 1 if we can write if tan inverse x plus tan inverse y plus tan inverse z is equals to pi by 2. Now solution. We have here the given condition. We have tan inverse x plus tan inverse y plus tan inverse z is equals to pi by 2. Now we know the formula of tan inverse x plus tan inverse y. So we can write, or this is tan inverse x plus y by 1 minus xy is equals to pi by 2 minus, we can write tan inverse z, or we have here tan we can write it here x plus y by 1 minus xy. This is equals to, we can write it here cot times tan inverse z here, pi by 2 minus tan inverse z, and then we remove it here tan inverse. So we can write our x plus y by 1 minus xy is equals to, here is cot times tan inverse z is, we can write cot inverse 1 by z, because we know tan inverse x is equal to 1 by tan inverse x is equal to cot inverse 1 by x. We know this formula. So instead of tan inverse z, we use cot inverse 1 by z. So this means cot times cot inverse 1 by z is, we can write 1 by z. So x plus y by 1 minus xy is equals to this one. By cross multiplication, we can write it here xz plus yz is equals to 1 minus xy. Now we have to prove it here, xy plus yz plus zx is equal to 1. So let us bring this xy also in this side. Therefore we can write xy plus yz plus zx is equal to 1. This one is so proved. Here LHS is equal to RHS. This is our question. So this one is proved. So in this way we prove this formula also by very easy method. Now example 11. In example 11 also we have a question. Prove that suppose tan inverse 3 by 5 plus sine inverse 3 by 5 is equals to tan inverse 27 by 11. We make one question. So a solution. We have here solution. Let sine inverse, we have here sine inverse 3 by 5 is equals to theta. Then sine theta is equal to 3 by 5. Sine theta is equal to this. Now we have tan theta is equal to, we have tan theta is equal to कति हुन्छ हेर्नुस् त tan theta भनेको हामीलाई थाहा छ sin theta by cos theta. So sin theta means, okay, we can write sin theta now. Sin theta by cos theta means in terms of sin theta मा लानु पर्यो 1 minus sin square theta. This is equal to sin theta is 3 by 5. So 3 by 5 by root under 1 minus 3 by 5 whole square. So this is equals to, we can write here, this is equal to 3 by 5 whole by root under 1 minus 9 by 25. Now this is equals to 3 by 5 whole upon root under 25 minus 9 by 25. This is equals to 3 by 5 whole upon, we can write 4 by 5 because 25 minus 9 is 16. Root 16 by 25 is 4 by 5. So this is equal to 3 by 5 times 5 by 4. This and this cancel is equal to 3 by 4 here. Tan theta is equal to कति आयो हेर्नुस् त tan theta is equal to 3 by 4 आयो. अब हामीले यसको LHS लियौं. Now taking LHS, left side हाम्रो कति छ tan inverse 3 by 5 tan inverse 3 by 5 plus sin inverse. Students, before this we have to show it here. Tan theta means we have 3 by 4. Therefore we can write tan theta is equal to 3 by 4. Therefore theta is equal to tan inverse 3 by 4. Here is also theta and here is also theta. So theta is equal to sin inverse 3 by 5. Here also theta is equal to tan inverse 3 by 4. So therefore we can write sin inverse 3 by 5 is equals to sin inverse 3 by 5 is equals to tan inverse 3 by 4. हेर्नुस् त यो हाम्रो इक्वल आयो किनकि यो पनि थीटा हो यो पनि थीटा हो. यो र यो इक्वल छ भने यो र यो पनि के हुन्छ अर्को साइड पनि इक्वल हुन्छ. अब हामी यसको LHS लिएर अब हामी यो प्रुभ गर्दै छौं. Now taking left side, we have here our left side is tan inverse 3 by 5 plus sin inverse 3 by 5. Now this is equals to, we know tan inverse 3 by 5 is, or we can write tan inverse 3 by 5 plus, instead of sin inverse 3 by 5, we can write tan inverse 3 by 4. Now tan inverse x plus tan inverse y is x plus y by 1 minus xy. So here is x is 3 by 5, x plus y is 3 by 4, x plus y by 1 minus xy. So x times y is 3 by 4. Now this is equals to, here we can take LCM. 20 and then 4 times 3 is 12 plus 5 times 3 is 15 divided by, here is also 20. So 20 minus 3 is 9. Now we are going to take LHS, left side. Our left side is tan inverse 3 by 5 plus sin inverse 3 by 5. So this is our LH. So this is equals to, we have tan inverse 3 by 5 and then plus, here is sin inverse 3 by 5 is equal to tan inverse 3 by 4. So instead of this we can write tan inverse 3 by 4. Now this is equal to, we know the formula of tan x plus tan inverse x plus tan inverse y is equals to x plus y tan inverse x plus y by 1 minus xy. We have this formula. So we are going to use the same. So x here, tan inverse x means 3 by 5 plus 3 by 4, x plus y by 1 minus x is 3 by 5 times y is 3 by 4. So this is equals to tan inverse we can take LCM here. So taking LCM, here is 20 and then 12 plus 15 divided by, here is also we can take 20 LCM, so 20 minus 9. So this is equals to 10 inverse. This one is 27 by 20 times 20 by 11. So we can cancel this. Now this is equals to 10 inverse 27 by 11. I think this is our answer here. 10 inverse 27 by 11. This is right side. Therefore left side is equal to right side, and hence proved. Hence in this way we prove this formula also by very easy way. Students, now we are going to solve another one question. That is the last example of this exercise. That one is example 12. Here in example 12 we have proved that sine inverse root under x minus b by a minus b is equals to cos inverse root under a minus x by a minus b is equals to, again, 10 inverse root under, here is x minus b and here is a minus x. We write the same, x minus b by a minus x. We have to prove this. Now solution here. To solve this question, we have to let it this one be theta, then we'll find this and then 10 inverse also. So let's look here. At first, let sine inverse root under x minus b by a minus b is equals to theta. Then we have sine theta is equal to root under x minus b by a minus b here. When sine theta is this one, then we can write cos theta here. Then cos theta is equal to root under 1 minus sine square theta. We know cos theta is root under 1 minus sine square theta. This is equal to root under 1 minus sine theta is root under x minus b by a minus b whole square. This and this cancel. So this is equal to 1 minus x minus b by a minus b. So this is equals to root under a minus b minus x plus b by taking LCM here. So we can cancel b and b. So we get a minus x by a minus b. We get this one. And then we can write this is cos theta is equal to this one. So theta is equal to, therefore theta is equal to, we can write cos inverse root under a minus x by a minus b. And students, we can suppose this is as a equation first and this as a equation second, because in equation first also here is theta, in equation second here is also theta, and this part is this first theta and this part is this second theta. Now we are going to find tan theta, because we started from cos theta and we found cos inverse. So if we'll start from tan theta, then we'll find tan inverse also. So here now we can write again tan theta is equal to, we know tan theta is sine theta by cos theta, sine theta by cos theta. So this is equals to sine theta by cos theta means root under 1 minus sine square theta. So this is equals to sine theta means we have here this x minus b by a minus b root under x minus b by a minus b whole by root under 1 minus sine square theta is also root under x minus b by a minus b whole square. We can cancel because we already found this by doing the same process. So this is equal to root under x minus a by x minus a minus b whole by, here is we can take LCM. So a minus b is LCM, so a minus b minus x plus b we can write here, and then this is equals to, we can put, this is also root under, this is also root under, we can put it single root, so we can write x minus a by a minus b and whole by, here this minus b and then plus b cancel, so a minus x by a minus b. So if we'll cancel, if we'll do reverse, and we can cancel this one, so tan theta is this, so theta is equal to, therefore we can write theta is equal to tan inverse root under x minus a by a minus x. It is x minus, once again x minus a by, we have to look it here once again, here is x minus b, we have to write it x minus b by this, here is also x minus b, and then here is also x minus b, we have x minus b by a minus x, theta is equal to, we can suppose this as equation 3. So combining equation first, second and third, now we are going to solve here combining equation first, second and third, or solving first, second, third, or from equation we can write from equation first, second and third. From equation first, second and third we'll get, first one is, this is also theta, this is also theta, and this is also theta, so all three are equal, therefore we can write, therefore sine inverse root under x minus b by a minus b is equals to, this is cos inverse root under a minus x by a minus b is equals to tan inverse root under x minus b by a minus x. This is the required answer of our question, and then we prove this one. So LHS is equal to middle side is equal to right side, so proved. In this way we solve different 12 types of question here in this exercise. Students, now we are going to start another one example of little different type of question again, that is example 6, and this is the last example of this exercise. Example 6. We can write question, if a is equals to 3, b is equals to 3 root 3 suppose, and then angle a is equals to 30 degree, solve the triangle. Now how can we solve this triangle? Also we can add it here, find in which case the solution is ambiguous. हेर्नुस् त कुन केसमा चाहिँ यो यो कुन केसमा चाहिँ यो सोलुसन चाहिँ एम्बिजियस हुन्छ भनेर हामीलाई सोधेको छ। यदि भ्यालु डबल आयो भने त्यो केसमा चाहिँ सोलुसन एम्बिजियस हुन्छ। अब हेर्नुस् है त यसको सोलुसनमा हामी सोलुसन we have a is equals to 3, b is equals to 3 root 3, angle a is equals to 30 degree. We have or we know we can write a by sine a is equals to b by sine b. हियर ए थाहा छ हामीलाई, बी थाहा छ अनि एंगल ए थाहा छ। त्यसकारणले हामी एंगल बी फाइन्ड आउट गर्न खोज्दै छौं। यहाँ हेर्नुस् है, ए मीन्स 3 by sin A means sin 30 degree is equals to B means 3√3 by sin B. We don't know the angle B, or we can cancel this and this. 1 by sin 30 is 1 by 2 is equals to √3 by sin B. By cross multiplication, when we'll reverse this one, यसलाई उल्ट्याउँदाखेरि 2 times sin B भयो, by cross multiplication is equal to √3, or sin B is equals to √3 by 2. sin को √3 by 2 कति डिग्रीमा हुन्छ त? or sin B is equals to sin 60 degree भनेको, here sin B is equals to √3 by 2. हेर्नुस् त, sin को √3 by 2 भनेको कति हुन्छ त? sin 60 degree or sin 120 degree. You know, here is in this case, here after school to college भनेर हामी इजिली सम्झन सक्छौं। यो all positive, sin positive, tan positive र cos positive हो। sin को यो सेकेन्ड क्वाड्रेन्टमा पनि पोजिटिभ हुन्छ, त्यसकारणले √3 by 2 भनेको 60 डिग्री फर्स्ट क्वाड्रेन्टमा पर्यो, 120 डिग्री सेकेन्ड क्वाड्रेन्ट पर्यो। Therefore we can write B is equals to 60 degree or 120 degree. यसरी B को हामीले डबल भ्यालु निकाल्यौं। अब हामी हेरौं, when B is equals to 60 degree, then C is equal to 180 degree minus A plus B. So this is equal to 180 degree minus A means we have 30, B means 60. 30 plus 60. So this is equal to 180 degree minus 90 degree. So its answer is 90 degree. Therefore C is equals to 90 degree. When C is equal to 90 degree, then we have A by sin A. A by sin A is equal to C by sin C, because here is given A. Now we have to find C. Either we can use B by sin B is equals to C by sin C also, because B is also given, and then angle B also we calculated here 60. Now, or A means we have here 3 by sin A means here sin 30 degree. Sin 30 degree is equals to C. हामीलाई थाहा छैन, so sin C is sin 90 degree. Or 3 by sin 30 is 1 by 2 is equals to C by sin 90 degree is 1. By cross multiplication, or 3 times 2 by 1 by reversing is equals to C. Therefore C is equals to 6. This is one answer. C is equal to 6. Now we use here when B is equal to 60 degree. हेर्नुस् त, अझै when B is equal to 120 degree भनेर हामीले निकाल्नु बाँकी नै छ। Now when B is equals to, we already use 60 degree. Now turn goes on 120 degree. When B is equal to 120 degree, then C is equals to, we have C is equals to 180 degree minus A plus B. So this is equals to 180 degree minus A means we have 30 plus B means we have here 120 degree. So 180 minus 150 means 30 degree only. And therefore C is equals to 30 degree. हेर्नुस् त, यहाँ C को भ्यालु 90 आएको थियो, अहिले यसको भ्यालु 30 आयो। त्यसकारणले हामीले फेरि यो अर्को C हामी निकाल्दै छौं, यो साइड C हामी निकाल्दै छौं। यसरी नै we can write then हामी त्यही फर्मुला युज गर्दैछौँ a by sin a is equals to c by sin c. A means we have 3 by sin a means sin 30 degree is equals to c by sin c is a is 30, sin c is also 30 degree. So here is c is 30 degree, so sin also 30 degree. This is also 30, this is also 30. We can cancel direct, we can cancel also. We can cancel. Therefore, c is equals to 3. This is another one answer. This is angle C and this one is side C. So here value of C is 3 and then C is 6. So we have here double value. So we can write solution is, here is asking in which case solution is ambiguous. So we can write solution is ambiguous because there is two solutions. We have two solutions. Therefore, we can write, therefore, B is equals to 60 degree, C is equals to, we have B is equal to 60 degree and then at that time C is equal to 90 degree. B is equal to 60, C is equal to 90 and then that side C is equal to 6 and we have, and we can write or here, or B is equals to 120 degree, angle C is equal to, we have 30 degree and then side C is equal to 3. This is the complete solution of this question. यसरी हामीले यो एक्सरसाइज को लास्ट क्वेशन पनि एन्ड गर्यौं. स्टुडेन्ट्स पक्कै तपाईहरुले यो लेसन को यो पाठ को हाम्रो यी 6 वटा एक्जाम्पलबाट अन्य यस्तै प्रकारका थुप्रै क्वेशनहरु तपाईहरु सल्भ गर्नु नै हुनेछ र यसको हेल्पबाट तपाईहरुले थुप्रै मनज्ञ फाइदा लिनु नै हुनेछ. स्टुडेन्ट्स, today we are going to start another one new topics. That one is inverse circular function. पक्कै तपाईहरुलाई इन्भर्स सर्कुलर फंक्शन भन्नाले कस्तो फंक्शनलाई बुझाउँछ पक्कै जान्न कौतूहल भइसकेको होला. त्यसमा हामी अझै त्यो भन्दा पहिला ट्रिगोनोमेट्रिकल फंक्शन र इन्भर्स सर्कुलर फंक्शन को बारेमा स्टडी गर्दै छौं. ट्रिगोनोमेट्रिकल function and inverse circular function. यसमा हामी यो भन्न सक्छौं, हेर्नुस् त, the functions f is equals to xy such that y is equals to sin x. यो f भयो. त्यस्तै g is equals to xy such that y is equals to cos x. Suppose h is equals to another one xy such that y is equals to tan x. This and this tan x are circular function known as here For this one we say sine, and this one cosine, and for this and tangent function respectively. अब यसको हामी चाहिँ इन्टरचेन्जिङ द रोल अफ एक्स एन्ड वाई भनिदिन्छौँ। हेरौँ है त, इन्टरचेन्जिङ द रोल अफ एक्स एन्ड वाई, we have f, capital F भनौँ यसलाई, f हेर्नुस् त x, y such that यहाँ हाम्रो के थियो, y is equal to sin x, इन्टरचेन्ज x लाई y, y लाई x भएपछि x is equal to sin y, x is equals to sin y। त्यस्तै फेरि this one is g is equals to x, y such that here is also x is equals to y is equal to cos x, means x is equal to cos y, and h is equals to x, y such that x is equals to, here is y is 10x, so x is equal to 10y, here 10y. Now these functions are inverse circular function. These functions are inverse circular function. These are inverse circular function. These are circular functions and these are inverse circular function. We conclude the inverse circular function, inverse circular function x is equals to sin y, x is equal to cos y, and x is equals to 10y are generally written as we have y is equals to here sin inverse x, and then x is equals to here means y is equals to cos inverse x for this one, and then for this one also y is equals to tan inverse x, and these are inverse circular function. Now let's just look what types of graph of circular function and inverse circular function. Students, अहिले हामी अब यो ग्राफमा हामी इन्भर्स सर्कुलर फंक्शनलाई कसरी शो गर्दैछौं हेर्दैछौं। फर्स्टमा y is equal to sin x को हामी हेरौं। सपोज एउटा हामीसँग ग्राफ छ। सपोज this one is x and then this one is y and this one is o. हेर्नुस् त हामीले यसरी एउटा कर्व बनायौं। यो कर्व भनेको y is equal to sin x को कर्व हो। हामी यो 0 0 भयो। अब सपोज यो हामी पाई बाइ 2 भन्छौं। यो माइनस पाई बाइ 2 यो माइनस पाई भयो। So similarly here is this one is pi by 2 and this one is pi, and here this one is straight, this one is 1 and here this one is minus 1. Suppose here is 2 and then here is minus 2, and this is the graph of y is equals to sin x. So we have another one graph. We have here like this one. So this one is pi by 2 and this one is pi. And so this one is 0, this is pi by minus pi by 2, and this one is minus pi. So here is this 1, and then here is 2. So similarly here is minus 1, and then here is minus 2. Suppose this one is x and this one is y, and this is the graph of x is equals to sine y, or we say y is equals to sine inverse x. This means y is equal to sine inverse x. So this is the graph of circular function y is equal to sine x, and this is the graph of inverse circular function, that is y is equal to sine inverse x. हेर्नुस् त यो यहाँ यो साइनको तपाईले जहिले पनि यो ओरिजिनबाट गएको देख्नुहुन्छ भने कसको फेरि जहिले पनि यो माथिको 1 बाट जान्छ। यसरी साइनको भ्यालु कहाँदेखि कहाँसम्म रह्यो त भनेर हामी अहिले पछि फेरि छलफल गर्ने छौं। अब हामी कसको हेर्नुस् त सर्कुलर फंक्सनको हेर्दै छौं। फर्स्टमा suppose this is x axis and this one is y axis. So we have here cos को हामीले we can make like this one. So this is 0 and this one is, we have here pi by 2, this one is pi, and this is 3 pi by 2. Similarly on this side here is, this one is minus pi by 2, and here we can make, this is pi, and then similarly minus 3 pi by 2, and this one is here, this is 1. Similarly suppose here is 2. Similarly here is minus 1 and then minus 2. It touches here. यो के को त हाम्रो हेर्नुस् त y is equal to cos x. This is the graph of y is equal to cos x. So the inverse of cos x is, we have here we have again little bit longer we are making. So suppose this one is pi by 2 and this one is pi and this one is 3 pi by 2. 3 pi by 2 and this one is pi and this one is pi by 2, and here is 0, and then this one is again minus pi by 2 and this one is minus pi, and then again the same way. So here we have like this graph. So here is this one, here is minus 1, and then here is this 1. So this is the graph of x is equals to cos y, or we can write y is equal to cos inverse x. This is the graph of this one. Here is 3 pi by 2 pi and then pi by 2, and then similarly here minus pi by 2, and then if we'll do like this, it goes like this one again. This is the curve of y is equal to cos inverse x. यसरी आउँछ। यो हाम्रो के त भन्दा यो x axis and this one is y axis. हेर्नुस् त यस्तो प्रकारको कर्व आउँछ यसको। भने हामीले जसरी यसमा हेरेका थियौं यहाँ 3 pi by 2 आयो, त्यसरी नै यहाँ हेर्नुस् त 3 pi by 2 यहाँबाट आयो, 3 pi by 2 pi and then pi by 2, pi and pi by 2। यसलाई भने हामीले अहिले बढी प्रोड्युस गरिराखेका छौं। नत्र हेर्नुस् त यो कर्व र यो कर्व ठ्याक्कै रिभर्स छ। Students, now we are going to show the graph of y is equal to 10x. So here we have here like this one. So the graph of 10x is, it comes like this. यसरी यसको ग्राफ आउँछ, यहाँ अलिकति हल्का टर्न भएर आउँछ यसरी। अब यो अवस्थामा हाम्रो हेर्नुस् त 10 को दिस वान इज, यहाँबाट हामीले हेर्यौं भने यहाँको नजिक स्टेट नजिकै आउँछ यो। And then similarly here, so this one is pi by 2, and then this is 0, and this one is minus pi by 2. Here we say this one is 1, 2, 3, 4 like this. This is y, and this one is x. So here is minus 1, minus 2, minus 3, minus 4. यसरी यो कर्व चाहिँ हाम्रो के को त भन्दा y is equal to 10x. y is equal to 10x को यो कर्व हो। ग्राफ हामीले हेर्यौं 10 मा यसरी आएको हुन्छ, यो कहाँ जान्छ भन्दा माथि इन्फिनिटी सम्म गएको हुन्छ। त्यस्तै यो 10 इन्भर्स को कस्तो हुन्छ हेरौं फेरि हामी। सपोज यो x एक्सिस छ, त्यस्तै सपोज यो y एक्सिस छ भने यसरी हाम्रो कर्व जान्छ। यसको कर्व हेर्नुस् है त, यो हाम्रो कति भयो त, यो पाई बाई 2, एन्ड दिस इज माइनस पाई बाई 2। यो हेर्नुस् त यसरी गएको हुन्छ। यस्तै फेरि यो यसरी जान्छ यो। एन्ड देन हियर वी क्यान राइट 1 suppose 2, 3, 4 like this. This is x axis, and then here is minus 1, minus 2, minus 3, minus 4, and this one is y axis, and this is the graph of x is equal to 10y, or y is equal to 10 inverse x. This is the graph of this one. Students, I think you know just the shape of sin x, cos x, 10x, and sin inverse x, cos inverse x, and 10 inverse x. हेर्नुस् त यो यसरी 10x को आयो भने यसरी आयो यो इन्भर्स को। त्यसकारणले यो इन्भर्स को र सर्कुलर फंक्शन को र इन्भर्स सर्कुलर फंक्शन को ग्राफ कस्तो हुँदो रहेछ तपाईहरुलाई अलिकति थोरै मैले यसको शेप मात्रै देखाउन खोजे। Students, now we are going to find the coverage area or domain range of this inverse circular function. हेर्नुस् है त, हामी यो एउटा टेबलमा देखाउन सक्छौं। सपोज function and then notation for principal inverse function. Similarly, defining equation. Similarly, domain, and then range. हामीले हेर्नुस् त भर्खर हामीले जुन ग्राफ हेर्यौं त्यो ग्राफकै आधारमा हामी यहाँ एउटा यसको कभरेज हामी हेर्दै छौं। हेर्नुस् है त, सपोज फंक्शन sin function को हाम्रो notation for principal inverse function is sin inverse we have here, and then defining equation is y is equals to sin inverse x, and then it's यसको चाहिँ हेर्नुस् त कहाँदेखि कहाँसम्म आयो भन्दा -1 देखि इज लेसर इक्वल्स टु x इज लेसर इक्वल्स टु 1 सम्म आयो यसको डोमेन। and then its range is minus 1 by 2 pi. 1 by 2 pi is less or equals to y is less or equals to 1 by 2 plus this is pi. Pi by minus pi by 2 देखि प्लस pi by 2 सम्म यसको रेन्ज रह्यो. त्यस्तै फेरि साइन भयो भने कोसाइनको हामी के लेख्छौं? cos inverse. So here is y is equals to हामी के लेख्छौं त यसको भन्दा cos inverse x. यसको पनि रेन्ज के हुन्छ त भन्दा -1 देखि +1 सम्म हुन्छ. So -1 is less or equals to x is less or equals to 1. अनि यसको चाहिँ यो रेन्ज के हुन्छ भन्नुस् त 0 is less or equals to y is less or equals to pi सम्म हुन्छ. त्यस्तै 10 को tangent we say for 10. So here is 10 inverse भयो यसको. So y is equals to 10 inverse x भयो. 10 को कहाँदेखि कहाँसम्म हुन्छ यसको डोमेन? हेर्नुस् त minus infinity is less than x is less than plus infinity सम्म हुन्छ यसको. प्लस इन्फिनिटी देखि माइनस इन्फिनिटी सम्म हुन्छ. माथिदेखि तलसम्म जुन हामीले अघि यो यसमा हेरेका थियौं. त्यस्तै यसको रेन्ज के हुन्छ त हेर्नुस् त. रेन्ज यसको माइनस यो पाई बाइ 2 अथवा 1 by 2 पाई is less than y is also less than 1 by 2 pi plus 1 by 2 pi. त्यस्तै हामी एउटा अर्को थप्न सक्छौं यसमा. त्यस्तै हामीले चाहिँ कोटेन्जेन्ट भन्नाले कट इन्भर्स हो यो. So y is equal to we can write y is equal to cot inverse x. यसको हाम्रो डोमेन के हुन्छ त भन्दा यही माइनस इन्फिनिटी देखि प्लस इन्फिनिटी सम्म हुन्छ यसको. त्यस्तै फेरि यसको चाहिँ फेरि यो रेन्ज के हुन्छ 0 भन्दा यो ग्रेटर हुन्छ एन्ड देन लेस कति भन्दा पाई भन्दा लेस हुन्छ. यसरी हामीले चाहिँ यो ग्राफको आधारमा हामीले यिनीहरुलाई यसरी डोमेन रेन्ज ले कहाँदेखि कहाँसम्म लिन्छ भनेर हामी यसलाई चाहिँ यसरी क्याटेगोराइज गर्न सकिन्छ. Students, now we are going to start to write some important formula related to the inverse circular function. So, some important formula. Some important formula. You can write it in number 1. Sin inverse sin theta. Sin inverse sin theta is equals to theta. Similarly we can write cos inverse cos theta is equal to also theta. Similarly, tan inverse tan theta is equal to also theta. This is the first formula. Formula number 2, we can write sin inverse x suppose is equals to sin inverse x is equal to cosec inverse 1 by x. Or we can write another one, cos inverse cosec inverse x is equal to sin inverse 1 by x. Here, sin and then cosec. Similarly, tan inverse x is equals to cot inverse 1 by x. And cot inverse x is equal to tan inverse 1 by x. Similarly, formula number 3, we can give sin inverse x is equal to cos inverse sin inverse x is equal to cos inverse root under 1 minus x square, and then cos inverse x is equal to sin inverse root under 1 minus x square, also same. Similarly, formula number 4, we give sin inverse x plus cos inverse x is equals to pi by 2. Sin inverse x plus cos inverse x is equal to pi by 2. Similarly, we can write tan inverse x plus cot inverse x is equals to also pi by 2. Similarly, we can write another one, cosec inverse x plus sec inverse x is equal to also pi by 2. This is in number 4. Now in number 5, we can write tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y is equals to tan inverse xy upon 1 minus xy. Similarly, we can write tan inverse x minus tan inverse y is equals to tan inverse we can write it here x plus y by this. Now in this case, x minus y by 1 plus xy, x minus y by 1 plus xy. Now the next formula. Now in number 6 is sin inverse x plus sin inverse y is equals to, we can write sin inverse x times root under 1 minus y square plus y times root under 1 minus x square. This is sin inverse x plus sin inverse y is equal to this one. So similarly, sin inverse x minus sin inverse y is equals to sin inverse x times 1 minus y square minus y times root under 1 minus x square. So we can write, instead of these two, we can write sin inverse plus minus this is equals to sin inverse plus minus this. Also we can write like this. Similarly, on the formula number 7, cos inverse x plus cos inverse y, cos inverse x plus cos inverse y is equals to cos inverse xy minus root under 1 minus x square times root under 1 minus y square. In this way, we read 7 different types of formula in these topics. Now we are going to start worked out example. Now let us start example number 1. Example 1. We use these above formulas and we'll find the required values. Now example number 1 is little bit easy also. Evaluate sin inverse 1. हेर्नुस् त, हामी sin inverse 1 कसरी फाइन्ड आउट गर्छौं? Solution. First, we have to let it sin inverse 1 is equals to theta. So let sin inverse 1 is equals to theta. So we can write sin theta is equal to, then we can write sin theta is equals to 1. And this 1 means we can write, 1 means sin 90 degree is 1, so we can write sin pi by 2 if here is sine out, then we can write therefore theta is equal to pi by 2. Therefore theta means we have sine inverse 1. So value of sine inverse 1 is equals to pi by 2. From this and this हेर्नुस् त थीटा भनेको यहाँ पाई बाई 2 आयो, यही थीटा भनेको sin इन्भर्स 1 हो, त्यसकारणले हामीले sin इन्भर्स 1 भनेको this pi by 2 भनेर यसको आन्सर हामीले फाइन्ड आउट गर्यौं. Students, now another one example, that one is example number 2. Example 2. So in this example also evaluate cos inverse minus root 3 by 2. Cos inverse minus root 3 by 2. Now solution. We have let theta is equals to cos inverse minus root 3 by 2. So we can write cos theta is equal to then cos theta is equals to minus root 3 by 2. Here is minus root 3 by 2 inside the bracket. Or we can write this minus root 3 by 2 is, we can write cos 150 degree. Students, you know root 3 by 2 is 30 degree, cos 30. So 180 minus 30 is 150. And in second quadrant cos is negative, so cos 150 degree. And let's convert this 150 degree in terms of pi. So we can write cos 5 pi by 6. 5 pi by 6 is 150 degree. So here is a cos theta is equal to, or cos theta is equal to this one. Therefore theta is equals to 5 pi by 6. When theta is equal to this, then we let it theta is equal to cos inverse x. Therefore cos inverse minus root 3 by 2 is equals to, here 5 pi by 6 is the required answer of this question. This question is very easy and very simple types of question in first two examples. Now we are going to look example 3, and that one is a little different type of question. Now example 3. Here in example 3, we are going to solve another type of question. Suppose express cos suppose tan inverse x in terms of x. Cos tan inverse x here in terms of x. So solution, we have here let here tan inverse x, we suppose tan inverse x is equal to theta. So tan inverse x is equals to theta. Then tan theta is equals to x. Tan theta is equal to x. Therefore here is cos. Therefore cos tan inverse x, cos, this is our question, cos tan inverse x is equal to cos, it means tan inverse x means we have here theta, so cos theta, this is equals to cos theta we can write 1 by sec theta. Here is tan theta, so we have to convert this in terms of tan theta. So this is equals to 1 by sec theta, means root under 1 plus tan square theta. So this is equal to 1 by root under 1 plus tan square theta, means 1 plus x square. So this is the required answer. So we can write, therefore cos tan inverse x is equal to 1 by 1 plus x square is the answer of this question. In example 4, we are going to solve another type of question. Okay, look here on example 4. Example 4. So in this example, we can write evaluate sine and then sine 10 inverse 3/4. Suppose this. Now solution we have here. We have to let it 10 inverse 3/4. So let theta is equals to 10 inverse 3/4. Then tan theta is equals to 3/4. Therefore, our question is, हेर्नुस् त अब क्वेशन सुरुवात गर्दैछौं, sin times tan inverse 3/4 is equals to sin यो tan inverse 3/4 भनेको हामीले हेर्नुस् त थीटा लेट गरेका छौं sin theta. This is equal to sin theta. Now we have to convert in tan theta, so we can write sin theta 1 by cosec theta. This is equal to 1 by cosec theta is again 1 plus cot square theta root under. The formula of cosec theta is root under 1 plus cot square theta. So this is equals to 1 upon root under 1 plus cot square theta. Also we have to change in tan theta. So 1 by tan square theta. Now this is equals to 1 upon 1 plus 1 by, there is root under tan square theta is, we have here tan theta is 3/4, so 3/4 square. This is equals to 1 by root under 1 plus 1 by 9/16. So this is equal to 1 by root under 1 plus, this is 1 times 16/9. So this is equal to 1 by root under 9 plus 16. 9 plus 16/9. So this is equal to 9 plus 16 is 25. 25/9 is 5/, so 1 by we can write 5/9. So reversing, this is equal to 9/5. Oh, here we can write here again, this is 25, root 25 is 5, so 9 is 3, so 5/3, and then here by reversing 3/5 is the required answer of this question. This is the answer of this question, sin times tan inverse 3/4. Students, now we are going to discuss about example 5. That is also little different types of question. So example 5 here, we have example 5. In example 5, we can write prove that suppose 3 tan inverse x is equals to tan inverse 3x minus x square, or 3x minus x cube by 1 minus 3x square. Solution. Here we have to let it tan inverse x, and then it will be if we let it theta, then 3 theta will come, and we can solve this question. So let tan inverse x is equals to theta, then we have here tan theta is equals to x. So we have to convert these all in terms of tan theta, then we'll find the required answer of this. Now our question is here 3 tan inverse x. So we have to do it here tan 3 theta. Tan 3 theta is equal to, you know the formula of tan 3 theta. You know, tan 3a is equal to 3 tan a, 3 tan a minus 10 cube a. 10 cube a upon 1 minus 3 tan square a. 3 1 minus 3 tan square a. Instead of a, we substitute here theta. Now this is equals to 3 times tan theta is x, 3x minus tan theta is x, so x cube by, here is 1 minus 3 tan square theta is x square, 1 minus 3 x square, or we can write or 3 theta is equals to, we have to write it tan inverse. Tan inverse here is tan inverse 3x minus x cube by 1 minus 3x square. This answer is coming here. So 3x minus x cube by 1 minus 3x square. So instead of this, here is 3, and then if the value of theta is here tan inverse x, so we can write therefore or we can write or 3 times theta is tan inverse x. Tan inverse x is equals to tan inverse 3x minus x cube by 1 minus 3x square, and we can write therefore here, and this is the complete answer here, LHS, and then this one is RHS. So left side is equal to right side. So proved. In this way, we prove this question also by very easy way. Students, now in example 6, we are going to solve another type of question. Okay, in example 6, we have here prove that tan inverse x plus tan inverse y plus tan inverse z is equal to tan inverse x plus y plus z minus x y z upon 1 minus yz minus zx minus xy. हेर्नुस् त, यसलाई हामी कसरी अब सल्भ गर्छौं। यो एकदमै इजी क्वेशन छ, हामी आइडिया लगाउन मात्रै जरुरी छ। सोल्युसन taking a left side, so our left side is tan inverse x plus tan inverse y plus tan inverse, we wrote z like this, z. This is equal to, we know the formula of tan inverse x plus tan inverse y, so that one is x plus y by 1 minus xy. This one is tan inverse this. Formula of tan inverse x plus tan inverse y is tan inverse x plus y by 1 minus xy, plus we have here tan inverse z. Now this is equal to, again we use tan inverse x plus tan inverse y, so we can add it x plus y by 1 minus xy on same way. So here instead of x, here is x plus y by 1 minus xy, so we need tan inverse this, and then this is x plus y means z. Here whole by 1 minus, this one is x, means x plus y by 1 minus xy times, this is 1 minus x y, here it's like this. So this is equals to tan inverse, let's take the LCM. So we have here x plus y plus z times 1 is z minus xyz, z minus xyz upon here is 1 minus xy whole upon, here is also taking LCM, 1 minus xy, 1 minus xy, and then minus x I and z minus xz, x I and z xz, minus y I and z minus yz upon LCM is 1 minus xy. So here 1 minus xy and 1 minus xy, when we will reverse and we can cancel. So this is equals to 10 inverse. Here is our maybe our RHS, this one 10 inverse. We can arrange this 10 inverse x plus y plus z minus x y z upon numerator is this completed, and denominator 1 minus yz is minus yz. We can write 1 minus yz and then minus zx is here, and then minus xy is also here, minus xy, and this is equal to right side. Therefore left side is equal to right side, hence proved. In this way, by easy way, we prove this question also. Students, now we are going to solve another one example that is also different types of question. Example 7, prove that prove that 10 inverse root x is equals to 1 by 2 cos inverse 1 minus x by 1 plus x is equals to 1 by 2 sine inverse 2 root x by 1 plus x. This is our question. Now we have to prove it here, left side, middle side, and then RHS side equal. So solution, we have let 10 inverse root x is equals to theta. 10 inverse root x is equals to theta. Then we have 10 theta is equal to root x. हेर्नुस् त, अब यो सबैलाई हामी चाहिँ के त यो 10 थीटा मा कन्भर्ट गर्छौं अनि x मा भ्यालु पुट गर्छौं र इक्वल देखाउँछौं. नाउ अब cos 2 theta is equals to we know the formula in terms of 10, 1 minus 10 square theta by 1 plus 10 square theta, because cos 2a is 1 minus 10 square a upon 1 plus 10 square a. So we have this is equals to 1 minus 10 square x, 10 theta is root x. So 1 minus 10 square theta is root x whole square by 1 plus root x whole square. This and this cancel, this and this also cancel. Now we have this is equal to 1 minus x by 1 plus x. We can write it here, cos, here is 2 theta. Therefore 2 theta is equal to cos inverse 1 minus x by 1 plus x. So theta is equal to theta is equals to 1 by 2 cos inverse 1 minus x by 1 plus x. I think here this is our second part. 1 by 2 cos inverse 1 minus x by 1 plus x. This second part we can say this is equation 1, and this one is equation, we can say equation 2, because here is also theta, here is also theta. This means LHS and this means middle side. Now again we have to prove this one. So again sine 2 theta is equal to, because here is sine inverse, so we have to start, here is 1 by 2, so we have to start from sine 2 theta. Sine 2 theta is equal to, in terms of 10 theta, to 10 theta upon 1 plus 10 square theta, and this means 2 10 theta means we have 10 theta is root x. So root x by 1 plus root x whole square. So this and this cancel. So we can write 2 theta is equal to we can write, or 2 theta is equal to 2 theta is equal to sine inverse 2 root x by 1 plus x. Here is 2 root x by 1 plus x. Then we can write theta is equals to sine 1 by 2 and then sine inverse 2 root x by 1 plus x, and we say this is equation 3. So from equation 1, 2 and then equation 3, here is theta, here is also theta, here is also theta. So this theta equal, therefore tan inverse root x is equals to 1 by 2 cos inverse 1 minus x by 1 plus x is equals to 1 by 2 sine inverse 2 root x by 1 plus x, which is here in the question. So we can write, therefore from equation 1, 2 and 3 we can write हेर्नुस् है त, हामीले के लेख्न सक्ने भयौं त, tan inverse root x is equals to second one 1 by 2 cos inverse 1 minus x by 1 plus x is equals to again 1 by 2 sine inverse 2 root x by 1 plus x. In this way proved. हेर्नुस् त, यो लेफ्ट ह्यान्ड साइड इज इक्वल टु मिडल साइड इज इक्वल टु राइट ह्यान्ड साइड भयो. यसरी हामीले यो क्वेसन पनि इजी वे बाटै प्रुभ गर्यौं. Students, now we are going to start another one example, that is example 8. On this example 8 we are going to solve different type of question again. Example 8. Example 8. Find the value of sine and then cos inverse, we can write 1 by 2 cos inverse 1 by 2 plus sine inverse 3 by 5. Solution. We have here solution. We have let it, here is cos inverse 1 by 2 sine inverse 3 by 5. So if we'll let it this suppose alpha or theta and this suppose beta, then sine theta plus beta will be here. Then sine a plus b formula will use sine a cos b, cos a sine b, and then we'll substitute the value and then we'll find the answer. So let's look here. So at first let cos inverse 1 by 2 is equals to theta and sine inverse 3 by 5 is equals to suppose beta. Then cos theta is equals to 1 by 2 and sine beta is equal to 3 by 5 we have here. Now we have to find, here is cos theta, so we have to find sine theta also. And now sine theta is equal to root under 1 minus cos square theta. So this is equal to root under 1 minus cos square theta is 1 by 2 whole square. So this is equal to root under 1 minus 1 by 4. So taking LCM, 4 minus 1 by 4. So this is equals to root 3 by 2. So sine theta is root 3 by 2. And here is, we have to find cos beta is equals to root under 1 minus sine square beta. So this is equal to root under 1 minus sine square beta is 3 by 5 whole square. So we have this is equal to 1 minus 9 by 25. So this is equal to 25 minus 9 by 25 root under. So this means 16 by 25. This means 4 by 5. Now we know cos beta and then sine beta, cos theta, and sine theta. Now we are going to use the question. We have here, our question is sine, again we have sine and then cos inverse 1 by 2 plus sine inverse 3 by 5. This is equals to sine. This means we let it already theta, and this means we already let it beta. So sine theta plus beta, sine theta plus beta. So sine A plus B means we know sine A plus B is, we can write here sine A cos B plus cos A sine B. B means beta, A means theta. Now let us substitute the value. Now we are going to do here. Now this is equals to sine theta means we have here sine theta is root 3 by 2. Root 3 by 2 times cos beta is, we have cos beta is 4 by 5 times 4 by 5. Similarly, plus cos theta is 1 by 2 times sine beta is 3 by 5. So this is equals to, we can multiply 4 root 3 by 5 times 2 is 10, plus here is also 3 times 1 is 3 by 10. So taking LCM, we have 10 is LCM here. So 4 root 3 plus 3 is the required answer of our question. Therefore we can write, therefore sine times cos inverse 1 by 2 plus sine inverse 3 by 5 is equals to 4 root 3 plus 3 by 10 is the required answer of our question. This is the value of this example 8. Now we are going to solve another one example. Students, now our example 9 is solve. We have cos inverse x minus sine inverse x is equals to 0. We have to find the value of x here. So solution, we have here cos inverse x minus sine inverse x is equals to 0, or we can write cos inverse x minus, students, we know one formula, sine inverse x plus cos inverse x is equals to pi by 2. So let us arrange in this form here. So we can take minus common like this one, then sine inverse x plus cos inverse x. We added here cos inverse x, and let's do minus cos inverse x. We subtracted cos inverse x again. If we'll cancel this, and then remaining is the question. So we can write cos inverse x minus the value of sine inverse x plus cos inverse x is here pi by 2. So we can write pi by 2 and then minus became plus cos inverse x. We open by minus also. This is equals to 0. Cos inverse x, we can write 2 cos inverse x is equals to pi by 2. It became plus. Or we can write cos inverse x is equals to pi by 2 times 2, or cos inverse x is equals to pi by 4. Therefore we can write cos x. Here we can write, therefore x is equal to cos pi by 4. When x is equal to cos pi by 4, we can write, or x is equals to cos pi by 4 is 180 degree by 4, and then therefore x is equals to, this is 45 degree, cos 45 degree is 1 by root 2 is the required answer of this question. And यदि solve त्यस कारणले हामीले x को भ्यालु फाइन्ड आउट गर्नुपर्ने थियो. This is the value of x.